Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0977 indicates a problem related to the shift solenoid valve B circuit in the Honda Civic models ranging from 2011 to 2015. This specific code is a clear indication of an electrical circuit issue rather than a mechanical failure within the transmission. The shift solenoid is a critical component in controlling the flow of transmission fluid, directly affecting shifting functions in the vehicle. It is located within the transmission assembly and plays a vital role in ensuring appropriate gear shifts occur as required. In the context of P0977, the electrical circuit feeding this solenoid is identified as problematic. Thus, effective troubleshooting starts with the electrical components supplying the solenoid rather than the mechanical workings of the transmission itself. The primary error presented by DTC P0977 is the failure of shift solenoid valve B, which services the automatic transmission of the Honda Civic. This solenoid is responsible for controlling the transmission fluid flow, which is crucial for proper gear shifting. Its failure to perform can lead to inappropriate or failed gear shifts, affecting the vehicle's performance. The solenoid is situated within the transmission assembly, typically near the valve body where other solenoids are located. When this DTC appears, the issue is isolated to the electrical circuit connected to this solenoid, rather than a fault in the mechanical parts of the transmission. This vital distinction means that troubleshooting will focus on the associated wiring, connectors, and fuses. The immediate approach involves verifying the integrity of the associated electrical components. Several factors can lead to the activation of DTC P0977. Primarily, this DTC results from an electrical circuit problem, which highlights that the issue lies in the connectivity or integrity of the wiring or associated components, rather than in the mechanical operation of the transmission. A faulty fuse could disrupt the circuit entirely and is a vital point to check early in the troubleshooting process. Additionally, connectors, which ensure proper electrical flow between various components, can become corroded or loose, leading to intermittent issues. Finally, the possibility of a short circuit within the wiring harness can also lead to this DTC being triggered, requiring thorough inspection of the wiring for any signs of wear, damage, or improper insulation. When DTC P0977 is present, various symptoms may become apparent. One of the most common signs is poor shifting performance, where the vehicle might struggle to change gears smoothly or at all. Drivers may experience unusual delays or harsh shifts, making driving uncomfortable and potentially unsafe. Additionally, an unresponsive transmission can be a significant symptom, indicating that the solenoid's failure to operate properly is preventing gear engagement altogether. This failure may lead to the vehicle not accelerating as expected. Dashboard indicators, such as the check engine light, are typically illuminated when this DTC is present, alerting the driver to potential issues that require diagnosis and repair. These symptoms can not only affect driving experience, but also indicate potential secondary damage to the transmission if left unaddressed. The first step in troubleshooting DTC P0977 involves problem verification through a series of initial checks. Begin by turning the ignition switch to the on position, I, or pressing the engine start-stop button to initiate the on mode. This action provides power to the vehicle's electrical systems needed for diagnostic testing. The next step is to clear the DTC using a Honda Diagnostic System HDS tool, which resets the fault codes stored in the vehicle's computer system. Following this, it's essential to start the engine while ensuring the car is in park. Once the engine is running, allow it to idle for at least 10 seconds. After the idle period, the next step is to check for any pending or confirmed DTCs using the HDS. If DTC P0977 reappears, it indicates a duplicated failure, leading you to proceed to the next troubleshooting step. If the code does not reappear, the issue might be intermittent, and further investigation into previously recorded freeze data may be necessary to reproduce the failure scenario. The second step involves a thorough inspection of the vehicle's fuses to ensure they are functioning properly. Firstly, turn the ignition switch to the lock position, 0, or select the off mode using the engine stop button, ensuring all electrical systems are powered down before proceeding. The focus is on fuse number B7, which is a 15-amp fuse located within the under-dash fuse relay box. This fuse is a critical part of the wiring circuit associated with the shift solenoid valve B. If this fuse is found to be blown, replacing it is necessary to restore electrical flow. Should the new fuse blow again, it indicates a more severe underlying issue, such as a short to ground within the circuit connected to fuse number B7. If the fuse is intact, troubleshooting will need to progress to checking the wiring for continuity and signs of damage. In this third step, the focus shifts to checking the wiring associated with the IG1 miss-sol line to identify any potential opens within the circuit. Start by jumping the SCS, System Calculation Support line, with the HDS tool, ensuring diagnostic mode is appropriately engaged. After establishing the communication channel, disconnect the PCM Powertrain Control Module Connector A, which consists of 51 pins. This step is crucial because it isolates the circuit for testing. Next, turn the ignition switch back to the on position, 2, to apply power to the circuit. At this point, you will measure the voltage between test points 1 and 2, with test point 1 being the PCM connector A pin, number 1, and test point 2 connected to a reliable body ground. Under ideal conditions, there should be battery voltage present at this location. If correct voltage is measured, it helps confirm that the IG1 miss-sol wire is functioning correctly, allowing you to proceed to the next step. If there is no voltage, this indicates an open circuit within the IG1 miss-sol wire between the PCM and the number B7 fuse, necessitating repair work to address the connectivity issue. Moving on to the fourth step. The focus is now on assessing the shift solenoid valve B and its connections. Using the previous findings, check the functionality of the shift solenoid valve B to determine if it is operating correctly. This involves examining the connections, particularly at the PCM connector A, 51P, and ensuring that the terminal sides of the female terminals are clean and secure. Any corrosion or loose connections at these points can lead to intermittent or total circuit failure. If the solenoid valve is found to work as intended, the next step would involve verifying the condition of the wiring and connections leading back to the PCM. Following through with tests will help ensure the pathway from the solenoid valve through to the PCM is intact. If the solenoid valve does not operate correctly, further testing of the wiring harness or replacement of the solenoid might be necessary, leading to the subsequent troubleshooting steps based on these results. In the fifth step, the continuity of the SOL_B wire will be checked to ensure there are no open circuits disrupting functionality. To initiate, turn the ignition switch to the lock position 0, or ensure the engine is off. The next step is to jump the SCS line again using the HDS, ensuring diagnostics remain active. Following this, disconnect both the solenoid wire harness 8P connector and PCM connector B, 51P, to facilitate a proper continuity check. You will evaluate continuity between test points 1 and 2, with test point 1 being the connector pin located on the solenoid side, and test point 2 corresponding to the pin on the PCM side. If continuity is detected, it indicates the solenoid wire is intact. And if the PCM did not have the latest software, an update is warranted. If the PCM is confirmed to be functioning correctly, with or without an update, the troubleshooting will conclude positively. If continuity is not present, this suggests an open circuit in the solenoid B wire, signaling the need for repairs to restore connectivity. The final troubleshooting step involves checking the resistance of the shift solenoid valve B to uncover potential failures in the solenoid itself. Begin by removing the solenoid wire harness while ensuring the ignition is in the lock position, 0, or the engine is off for safety. Using a multimeter, measure the resistance between the two test points on the shift solenoid valve B 2P connector. For the solenoid to be deemed functional, the resistance should fall within the range of 8.9 to 12.2 ohms. If the measurement is within this specified range, the solenoid valve B is considered operational, indicating another potential issue elsewhere, such as a faulty solenoid wire harness that will require replacement. Conversely, if the resistance is outside the specified range, it confirms a failure of the shift solenoid valve B. In this scenario, replacement of the valve body is necessary to ensure proper operation of the transmission system and the resolution of DTC P0977. After completing all troubleshooting and repairs associated with DTC P0977, it is crucial to verify that the issue is fully resolved before concluding the repair process. Begin by checking for the reappearance of DTC P0977 using the HDS. If the DTC is no longer indicated, conduct a thorough inspection of all repaired circuits to ensure no new issues have emerged and that all connections are sealed and secure. This includes rechecking any terminals or connectors that were removed during the repair process. Additionally, performing a functional test on the shift solenoid valve B will confirm its proper operation and smooth shifting functionality. If all systems pass these checks without any further DTC indications, the repair can be deemed successful and complete. This final verification is a necessary step to ensure the vehicle operates efficiently and the driver can return to safe driving without transmission issues. Preventive maintenance plays a significant role in avoiding future occurrences of DTC P0977 and ensuring the longevity of the vehicle's transmission system. First and foremost, regularly inspect all relevant fuses, including fuse B7, to ensure they are in optimal condition and replace any blown fuses immediately. Additionally, maintain clean and secure electrical connections throughout the vehicle, as corrosion or dirt buildup can hinder electrical flow and may lead to DTC activation. Furthermore, it is crucial to monitor vehicle performance consistently, keeping an eye out for any unusual shifting behavior or dashboard alerts indicating electrical issues. By adopting these preventive measures and being proactive about maintenance, the likelihood of DTC P0977 reappearing can be substantially reduced, leading to a more reliable and well-functioning vehicle. In conclusion, DTC P0977 signifies a significant electrical issue concerning the shift solenoid valve B circuit in Honda Civics from 2011 to 2015. Understanding that this issue does not stem from mechanical failures is essential for directed troubleshooting. It emphasizes the need for meticulous inspection of electrical components, such as fuses, wiring, and connectors, to identify and rectify faults. Our troubleshooting guide systematically leads through problem verification, fuse checks, wiring inspections, and solenoid evaluations, ensuring a comprehensive approach to tackling the fault. Finally, reinforcing preventive maintenance practices will ensure the vehicle remains in optimal condition and will help prevent similar circuit-related issues in the future. With rigorous follow-ups and thorough checks, drivers can safeguard their transmission's reliability and performance. Please like and subscribe to the channel. See you next time.